and welcome to part 6 of Caliburn Micro Introduction series. Today we will talk about screens and conductors. In Caliburn Micro, one of the main building blocks of application is screens and conductors. In theory, a screen is a single visible part of application. While it is hard to come up with a specific definition, you can think about it as a single page in a web application. A conductor is also a screen that has more screens inside of it and manages their flow. That means it decides which of the screens inside of the conductor is being displayed and which are not. In practice, they are both just classes in Caliburn Micro that our view models can inherit. And by inheriting, we declare that one view model is a screen, another view model is a conductor. So I have prepared an application to demonstrate how screens and conductors work. So this is the hierarchy of our application. So screens and conductors allows us to construct our application in a hierarchical way. So the parent of this hierarchy is the shell view model, the application window. Inside we will have two conductors. One is login conductor view model and the second one is content conductor view model. And inside these conductors we will have a login credentials view model and login two-factor authorization view model. That means our login will have two screens. First we will enter credentials, then we will enter two-factor authentication, and after that we will navigate to the content of our application. There we will have a header menu, and we will also have two screens. One is for home and one is for settings. So the login conductor will manage when to show the login credentials screen and when to show the two-factor authorization screen. And content conductor will manage when to show home view model and when to show settings view model. And I have also included here a header view model that is neither a screen or conductor. It is just to show that not every view model in our application is screen or conductor, because we don't have any specific logic for its activation. It will be visible always, so it is not needed to have it as a screen or conductor. Okay, first I will show you how the application looks, and then we will jump into code and try to analyze it. So here we have a screen that allows you to enter user credentials. You press continue. If they are correct, you are asked to enter two-factor authentication code. I have not implemented the logic, of course, it's just an example. You press continue and then you are navigated to the content of the application. First, the default screen is a home page. In the header menu, you can navigate to settings page, navigate back to home page, and that's it. So the starting point of our application is the shell view model. It is the application window, and it will be the first view model to be shown on startup. Here, by inheriting from a conductor, we specify that this shell view model is a conductor. There's multiple implementations of conductor inside Caliburn Micro. One of them is on active. That means only one screen is active at a time. There's also another implementation, all active, but the most common one is on active. So we will use this one in this example. So as I mentioned before, conductors inside of them has screens as childs, and they manage which of these screens are being displayed. A conductor is also a screen itself. So here we, to this shell view model conductor, we inject login conductor and content conductor and add them as child items. Then we override on activate method that will be invoked when this shell view model is being shown. And we call method activate item login conductor view model. This will set a property that all conductors have called active item to point to this login conductor view model. Here, this is the property. And we want our view to show this active item. That will be the screen that is being shown. So we do it like this. This is just some garbage left from my testing. We don't need that. Okay, so when the shell view model is shown, it will show the login conductor as its child item. Now let's jump into the login conductor view model. Here we see that login conductor is also conductor. I like to name my conductors with conductor keywords so I can easily tell which of the view models are screens and which are conductors. For example, this one is a screen, and this one is a screen, and this one is a conductor. Yeah, so let's get back to that. We add 2 screens as child items for login conductor. That is login credentials view model and the login two-factor authentication view model. And when we show this login conductor, on activate method will be called, and the first item to be activated will be in the credentials view model. So the credentials screen will be displayed. Now let's look into the login credentials screen. Here we see that it is a screen. It has no logic, just one method, continue, that will be invoked when we press continue button in the credentials view. And it will publish a message, valid login credentials entered. Of course, here you would have the logic to validate if the credentials are correct. For demo purposes, we don't have that. Okay, so it will publish this valid credentials entered message, and the login conductor will listen to this message, as I explained in previous part of this series about Event Aggregator. And it will handle this message and activate the two-factor authentication view model. Now we have this login two-factor authentication view model displayed on screen. Let's look into the view model. It also has one method, continue, that will be invoked when we press this continue button. And it will publish another message, successfully authenticated, or not, if we add logic here. And this message will be handled by shell view model. That means our login flow has ended, and now we display content conductor view model. First we had this login conductor displayed, and it managed the flow of 2 login windows. Now we passed that and we show the content. So in content conductor, we see that it's conductor, and we have 3 view models injected into it using dependency injection. However, only 2 of them are actually screens, and the header is just a view model that is not a screen because it does not have any activation and deactivation logic inside of it. Same as before, when we activate this conductor, we activate the home view model first. If we would take a look into the content conductor view, we will see that we have a grid of 2 rows. In the first row we have the header. In the second row we have the active item property from conductor class. So header is always present on this screen, and the active item will be managed by the conductor. Inside the header view model we have 2 buttons, home and settings. And that will publish a message, navigate message, either to home or settings page, and the content conductor will listen to these messages. Oh yeah, it's only a 1 message with different parameter. So the content conductor listens to 1 message, and when it catches the message, it checks which of the parameter page, the property page is set. If it's home, it will activate the home screen. If it's settings, it will activate the settings. So as you see, conductors are a pretty useful tool for managing the flow of the application and handle which of this screen or component in your application is being displayed and which are not.